And try to explain where words and ideas fit in the world of computing. And I'm going to try to explain something that I believe is not necessarily controversial, but it is something that is not part of common discourse in computing. We don't normally do what I'm about to do. So I'm going to pick a rather random idea that's used by programmers and by people who interact with programmers to try to describe something they want. Say they want some new kind of functionality. I'm not going to examine the word functionality because we'll save that for another time. And the first thing that someone suggests, either the computer person suggests or the person who's going to be distributing this functionality suggests is, well, all right, we'll create a module uh, for it. So let's look at this word module. It has these kinds of, uh, how should we say, physical, mechanical kinds of and product oriented kinds of associations. It's something that, in a sense, everybody has some sort of a um, intuitive sense of, in the sense of that it could be something we didn't even learn. When we talk about a module, we talk about some thing that we're plugging into some other thing, and that together that new thing has integrated in some fashion that then it has new capacity. And seems to be a pretty old idea that is not very far related from our ability to just put two ideas together. And if you think of a module in that way, as you could think of it as highly defined, that is very, very like some sort of shining sphere of some sort, um, a geometric entity, not necessarily one that you would find in the real world. And it has some sort of a very well-defined interface, and it plugs into some other contraption. So that's a module, and you can, of course, substitute the word module for lots of other things, and that has been done. But in any case, that idea of a module is not necessarily a module in real life uh, from a programming point of view, or even from a point of view of like looking at the world and trying to figure out what's going on in the world, which is something we call natural science. So in the natural sciences, when you say something is modular, you aren't necessarily saying, oh, it's a sphere that's going to be plugged into something else and it's going to give it magical new functionality. So instead, we say a module is something that is an idea in our heads of some sort of coherent or somewhat identifiable set of properties and operations, and make a list of things, words that we give for stuff in the real world, are ontology or ontological claims, if you will, about the thing that we're going to study. And we say, well, that is modular in the sense that I can kind of mostly say that it's this and it's not that. And in any case, and if you can get enough agreement about what that module is from a point of view of the thing that we're looking to find out more about, then module and modular decomposition of problems is not so crazy, because you're leaving a fairly loose and open definition. You're not saying it's a perfect sphere. You're not saying it's a reduced thing that doesn't interact with anything else except in particular ways. So a cell is an example of something that we could study in a 10-cell system. We might want, and where each cell is distinct in some fashion, we might want to say that, all right, the cell is a kind of module in this little 10-cell biological grouping. Well, we're not being reductionist necessarily if we don't act on it in a reductionist way. In other words, we're not overly defining or overly restricting what we mean by a cell if we keep in mind that the cell's interaction with other cells, the products that the cells leave behind, the way that the cell, when it is going through various stages of its developmental process, interacts with the environment around it, and the way that it interacts with the environment around it during its lifetime, during its morphogenesis, during its evolutionary history. All these things can open up the rather simple, mental idea we have that it's some sort of a little module. It's a little nugget. It's like this spherical, this spherical idea of a module. So, in any case, module can be a very loose thing that could be extremely biologically based. In other words, it could be a module, could be a field of some sort of an influence throughout an entire system. It could be like gravity. Let's look at the gravity module in this physical system. There may be other things entailed in the modeling of that system. Gravity is one of them. So we could say it's the gravity module. It's not necessarily asserting anything else than that we have we have taken these particular sets of our interests and separated them from each other, and the gravity is one of those sets of interests, and we're going to call it a mod. We're going to call the program that implements it a module. That is the program that implements those parts of it that we understand somewhat, at least the theory of it. We understand our theory about it somewhat, and it's got to interact with other modules, other sets of ideas, and other topics. So the word module is complicated in the real world and sort of simple in the mind when you don't think about it too much. The point is that you can actually abstract while keeping in mind the fact that it's a more complex thing. So we could say there's a language module in our brain. There's nothing wrong with saying that. That is the things that we are interested in studying that relate to language and don't relate to, say, indigestion, or don't relate to, say, the growth of my fingernails. These are the things that we're going to be studying, and so the topic is, or the object of study, or however you want to talk, or the subject of discourse, or whatever it is you would like to say about it, that module is going to be language. So there's a language module, right? There's nothing wrong with saying that. It's actually the kind of beginning of research. You wonder, where is language, the language module? You may be wrong about there being something that you could separate from everything in some fashion. It may be highly integrated in the sense that, all right, there is something that we can identify from the outside, but when you look inside, there's nothing there. It's an impression that we have of things. It's there are lots of possibilities, but you keep those things in mind from an epistemological point of view when you make an ontological claim about the existence of something. That is, you are saying there is a language module. You are saying there's a functional module in my operating system that deals with prioritizing processes. There is, whatever you're doing, there's a module for it, because a module is just an idea in our head of separating things from other things. And we need to sort of stay aware of that and not become too dogmatic about what any term that we use in engineering means. It's really silly when this happens, because it happens within the framework of a particular set of theories which will develop particular meanings and attach particular meanings to words. And those words start getting used as bludgeons against people who are using them in different theoretical frameworks, or using it in a kind of a non-theoretical sense. That is, they're using it as in a normal, what we'd call a native sense of beginning to approach the problem, until we turn the problem into something like the beginnings of a theory or a model regarding the thing that we're building or studying. So anyway, watch out for dogma. Watch out for over definition of terms. I think in the computer world, it's rampant, and almost every movement. I feel that movements that attempt to take words and use them for particular purposes cause problems. They at least cause schisms, and these are mostly communication schisms. And this is not something that really, it doesn't happen in the natural sciences in quite that way. I mean, it does happen when people who are not deeply involved in the science. They'll say, "You told me that was this was a species that was different than that species, but they seem to be the same. They're just in different locations geographically." Uh, the conventions that govern the naming of things and the naming of bits of theories, the naming of or the use of technical terms that have to be, sort of gradually refined in order to be useful. All these things are fairly open, and I think it's a very big problem in the natural sciences, but it's an even bigger problem in engineering, and even a bigger problem in computer engineering, where I can take any word and assign a sort of a new value to it, and if I get enough followers, then I can lead the fashion to only use this word for this particular thing. So we have to realize that these things are all in our heads. They're not very well defined. They're not nowhere near as well defined as we think they are, and there's no absolute truth regarding them.